Okay, so in this video we're looking at lines of best fit and types of correlation with scatter graphs, and let's get into it. So you can draw a line of best fit on data, and a line of best fit roughly follows the pattern of the points, and you've got this point below also. It does not have to go through any of the points or start on the axis. What does that really mean? Well, let's look at the first kind of correlation that you can have. And here you can see you've got positive correlation, okay? And it says as one value increases, the other value also increases. So you can see here with all of these points here, as we start off really small, okay, this is also really small, but as we get bigger, this also gets bigger. And to give an example here in context, we looked at on the previous video, you could have something here like temperature, and I'm gonna have to write it kind of above here, which I shouldn't do, but it should be below the axis, but it could be temperature here, for example, and then you could have sales of, let's go and say ice cream over here, okay, because you're saying here, right, when the temperature, for example, is really low, like this point here, the ice cream sales, as expected, are really low. But as the temperature gets much hotter, you begin to sell more ice cream. So you call this positive correlation. Now, a line of best fit is this blue thing here, okay? And it roughly follows the pattern of the points. So you can see here, you've got this kind of positive upwards trend, and it follows roughly the pattern, okay, of the points. Now, this is really important. It does not have to go through any points. So you can see that, right? You've got all of these points here, and the line doesn't actually go through any of them. And also, it doesn't start on the axis. It doesn't start at the point 0, 0, okay? Now, what is important with a line of best fit is it's got to have kind of roughly the same amount of points either side, roughly. Okay, so you can see here, here's your line of best fit. You've got kind of 1, 2, 3 points to this side of it, and over here you've got 1, 2, 3, 4. So it's kind of splitting the points in half, okay? And it's showing the trend that's going on here. Now, the next example here, you've got negative correlation, which says as the one value increases, the other decreases. And we saw in the previous video, an example of this could be something like, it could be like age in years, for example. And it could be over here, like the value of a car, okay, in thousands of pounds, for example. Because, right, as a car is really young in years, like if you just bought a car, let's just say after maybe like 1 year, the value is still worth a lot because the car is really new, everything's still working well. But as the age increases, as the car gets really, really old, okay, the value of the car begins to massively decrease, okay, because parts go wrong, things go wrong. So you have this negative trend, and we call this negative correlation. As one value increases, so as the age increases, the other decreases, right? The value of the car will decrease, okay? And again, your line of best fit is this blue line here, and it's showing the trend of the data, okay? It roughly follows the pattern of the points. And again, it doesn't go through all of the points, okay? And it doesn't start on the axis. You can see here, it's not going through actually any of the points, really. Well, not the center of them. And it doesn't start on the axis. It doesn't start sort of down here or anything. But it does show the pattern of the points. So you've got positive correlation and you've got negative correlation. And then last but not least, you've got no correlation. There is no pattern in data, and therefore there is no line of best fit, and that's really, really important. But first of all, right, you can see there's no pattern here. It's random almost. So for example, you could have something like, I don't know, shoe size for this axis, and something that's completely unrelated to shoe size would be, I don't know, your maths test mark, okay? Because, right, as your shoe size increases, will that mean that your maths mark gets bigger, for example? No, it's just a random relationship. Hence, the points are just all over the place. And here, it is definitely inappropriate to use a line of best fit, okay? You couldn't just go and draw this in and say, well, you just said that you have an even number of points on either side of that line. Well, you do roughly, okay? You've got 1, 2, 3, 4 over here, and you've got 1, 2, 3, 4 over here. But, you know, there's no pattern here. There's no relationship. So you cannot use a line of best fit if there's no correlation. Okay, so you cannot have this here because it doesn't make sense, right? There's no relationship here at all. Similarly, right, if you had something like this, so let's go and draw a bit of an axis over here. And if you had, let's go and draw some points over here. If you had this, okay, like points like this, okay, so basically what I'm trying to say here is, right, for all of these three here, this one here, and this one here, these are linear relationships. They're in a sort of straight line. So you can say that these ones here, these have a linear relationship. okay, because they're roughly following a straight line pattern. This here isn't. You can see it's more curved. It's a more curved relationship. So again, also for this one, it would be inappropriate to use a line of best fit, something like that. That would be inappropriate because you can see here, this here is a straight line and the data is curved. Okay, so this is, you would say if these are linear, this kind of relationship is non-linear. Hence, you cannot use a line of best fit because the relationship is non-linear. It's not a straight line relationship. Okay, you've got a curve there. Okay, so just a few things there just to recap. Right, correlation, you've got three types. You've got positive correlation, you've got negative correlation, and then you've got no correlation. And a line of best fit can be appropriate if you've got positive correlation and it's linear, or if it's negative correlation like this and it's linear. Okay, but a line of best fit is also not appropriate if there's no correlation or if the relationship is not linear. Okay, now let's look at an example of using a line of best fit. And we've got some questions here and we've got some data over here of science mark again against maths mark. And it is saying, right, part A pupil scored a mark of 50 on their science test. Okay, so they got 50 on the science test, but was absent for the math test. Use line of best fit to estimate the score, they would have achieved. Now, so because you can see here, first of all, which is really important, and we looked at this in the previous video, this example, actually with the maths mark down here and the science mark over here, but it doesn't make any difference for this example, which way around they go. But you can see here, apart from this point up here, which we'll come on to in a second, you've got a kind of this positive trend, right? You've got a positive correlation going on. You're saying as the science mark increases, so if you start off really low science mark, your maths mark is also low, but as it increases, okay, so for example this point here, the maths mark also increases. You have this positive relationship. Okay, so we can go and draw a line of best fit. I'm going to go and ignore this point here because this point, as we'll come on to later, we call this thing here an outlier, okay, or an anomaly. But let's go draw a line of best fit, and it's going to go roughly through all of the points. Something like that looks pretty good to me, okay, because you can see you've roughly got the same amount of points either side of that line, okay, roughly, and it's following the trend. Now look, just depending on how you do this, okay, it might vary. You might have drawn it a little bit differently like that, for example, or you might have drawn it like that. Okay, there will be some variation here, which is why it is an estimate in the question. Anyway, they get 50 on the science test, so let's go and now put that onto our grid. So science is here, and 50 is going to be about here, and we go up to my line now, which means I can go across to my maths mark and estimate what they're going to get, which looks pretty in the middle between 50 and 55. So I'm going to say probably that value there is going to be something like 55. So I would say 55 is what they would achieve for their maths mark. Okay, and that is that. So I've used my line of best fit to help me answer the question. Now part B is saying a pupil scored a mark of 60 on their maths mark test, but it was absent for the science test. So kind of the opposite way around this time. They got 60 on the maths, and I want to estimate the science test. Okay, so let's go and do that on my grid. Let's go and do it a different color this time. Let's go and do it in red over here. Okay, so 60 on the maths, which is going to be over here. I go to my line of best fit once that's been red. There we go, 60. I go across. There we go. And I go down. There we go. I'm going to say, to me, this looks like it's about 58 roughly. You can't be exact, but approximately, because it is an estimation, I would say about 58. And that is your answer for this one. And let's highlight it in yellow. Now, part C says, which data point is an anomaly? Now, an anomaly means outlier. Okay, so it also means kind of outlier. They mean the same thing, as I've labelled it on the diagram already. Up here, outlier, which I've done it in green. Okay, and an outlier means it doesn't fit the trend. So which point is an anomaly? I've labelled up here, this one here. Circle it, which I've already done, so that's good, and explain the context. What can you conclude about this statement, students? So just by looking at this point here, you can see, well, their maths mark is really, really high. Okay, they've got a really, really strong maths mark. It's about 88, I think. And then their science mark is pretty low. Okay, about 34-ish, isn't it? Roughly. So you can conclude that they're really good at maths and their science is not so good. Okay, that is what you're concluding. So what's good about these is you're putting it into context, into a real life situation. So we can conclude, I'm going to go and type it up so it's a little bit neater. We can conclude that the student is strong, is very good at maths, because he had a high maths mark, and he struggled with, or he is not so good at science. Okay, and that's it. Okay, so I'm gonna that's gone off the page bit, hasn't it? So let's go move this across a little bit. Hopefully you can see that. Or right, I'm gonna zoom out. Actually, let's zoom out. That will work. There we go. Okay, perfect. Good. Perfect. And that is it for this video. I think that is it, isn't it? So thank you for watching. Hopefully you've got a good understanding now of the different types of correlation. So you've got positive, negative, no correlation, and you know what a line of best fit is. Thank you for watching.